up to this point, as far as talking about derivatives, we haven't done any trigonometry. Changing that now, we're going to get the derivatives of all the 6 basic trig functions. So first problem here, let f of x equal sine x, find f prime of x. Well, the only tool we have for this would be the definition of the derivative. So that's where we'll start. And now apply the function, which is sine x in this case. And so this becomes the limit as h goes to 0, of sine of x plus h minus sine of x all over h. Now we're going to need a little trigonometry recall here, which is this. It's sine of alpha plus beta. So way back when you took trigonometry, you learned about the angle addition formulas, or identities. And it turned out the sine of alpha plus beta was sine of alpha, cosine of beta, plus sine of beta, cosine of alpha. Now you do not have to remember that. It'd be nice if you did, but you can live most of your Calculus 1 life without knowing that formula. But we are going to need to know that right now. And so that's the limit as h goes to 0. Then applying that formula, I'm going to have sine x cosine h plus sine h cosine x minus sine x all over h. Now, disclaimer, I am not going to ask you to reproduce this. Going through this to show how various things that we've done all tie together. Now, doing some magical rewriting, because I know where I'm going on this one. Just going to do a little rewriting here and bring that negative sine x up front. So negative sine x plus sine x cosine h plus sine h cosine x all over h. And then I'm going to split this up into 2 fractions, which is fine. And I'm going to have negative sine x plus sine x cosine h all over h plus sine h cosine x all over h. That's perfectly fine. You can split up numerators. You can never split up denominators, but split up numerators. And then I'm going to split this up into 2 separate limits, because one thing we learned about was that limits could be split up by addition or subtraction. And not only am I going to split it up into 2 separate limits, I'm going to do a little factoring on this first one. So factoring out a negative sine x, that's going to give me 1 minus cosine h all over h, plus then the limit as h goes to 0, is sine h cosine x all over h. Okay, so far, a little calculus to start us with the definition of the derivative, then a little trigonometry, and now just a bunch of algebra, and then a little bit of calculus that we could split up those limits. Then here's a little more algebra, calculus, whatever. The variable on the limit is h. The variable on the limit is h, which means the sine x and this cosine x, those are constants as far as limit's concerned. As far as limit's concerned, that's no different than saying 3 and 12 there. They are constants as far as the limit's concerned. The variable on the limit is h. Sine x, cosine x, no h's. So those guys can factor out, because that's one thing we learned about limits, that you could factor out constant. So that's what I'll do there. Because as far as the limit is concerned, the variable is h. So if it doesn't have an h and it's just a multiplied constant, it can be factored out. And then once upon a time, we learned that the limit as h goes to 0 of 1 minus cosine h over h was 0. And we learned that the limit as h goes to 0 of sine h over h was 1. And so we get cosine x. And so what we just showed was the derivative of sine x is cosine x. Now you are not going to be asked to reproduce this, But by doing, what I wanted to do by showing this is how all this stuff tied together. Here's my definition of the derivative. Here's some trigonometry that we brought into play. Then 2 special limits that we have from chapter 2 all gives us now that the derivative sign is cosine. In a very similar manner, you can find that the derivative of cosine is negative sign. Again, you're not going to have to reproduce this, but you do need to know these facts. Derivative of sine x is cosine x. Derivative of cosine x is negative sine x. Okay, let's work on the next guys. Let f of x equal tangent x, find f prime of x. You could do a similar thing that we did before, but we have other tools in our chest, so we're going to do something else that'll be easier. Tangent is sine x over cosine x, and then we're just going to use the quotient rule. So using the quotient rule, plain denominator, derivative of the numerator, minus plain numerator, derivative of the denominator, all over the plain denominator squared. Plain denominator, derivative numerator, plain numerator, derivative denominator, plain denominator squared. And you don't have to show that step. I've said that before. That's just me trying to teach people what the quotient rule says. So now actually doing it, plain denominator, then we just learned the derivative of sine is cosine. Plain numerator, then we just have right above it, the derivative of cosine is negative sine x, all over cosine squared x. So I have cosine squared x plus sine squared x all over cosine squared x. And that certainly is true, but that is not what we want to memorize here. There's some trigonometry staring at us in the face, and if there were people in this classroom, I'd ask the classroom what cosine squared plus sine squared is, and hopefully everybody would tell me that that was 1. And then a little bit more trigonometry, 1 over cosine squared x is secant squared x. And so we just showed that the derivative of tangent x is secant squared x. And then you can do an incredibly similar thing and show that the derivative of cotangent x is negative cosecant squared. Again, you want to memorize these. You don't want to have to go through every time that you need the derivative of tangent. While this wasn't particularly hard to do, you don't want to go through each time figuring out what the answer is. Memorize the derivative of tangent is secant squared. And the last one we're going to do, as far as coming up with these guys, we'll do the same thing we did for tangent, but this time for secant x. So f of x equals secant x, which is 1 over cosine x, and we're going to use the quotient rule again. So quotient rule, plain denominator, derivative of the numerator, minus plain numerator, derivative of the denominator, all over the plain denominator squared. Plain denominator, derivative numerator, plain numerator, derivative denominator, plain denominator squared. And again, you do not have to show that step when you're doing the quotient rule. Plain denominator, so don't do anything. Derivative of the numerator is 0, and it's times 0, so I need to write that 0 down. And then minus, then the derivative of cosine x is negative sine x over cosine squared x. And so I get sine x over cosine squared x. That is not the answer I'm going to memorize. Doing a little bit of rewriting. and showing every step I can think to show. I'm going to put an explicit coefficient in there. And then I'm going to split that up to 1 over cosine x times sine x over cosine x. And then doing some trigonometry, that becomes secant x. 1 over cosine x is secant x, and sine x over cosine x, tangent x. And so what we just showed is the derivative of secant x is secant x tangent x. And you want to memorize that. Yes, you could figure it out every time you need it, but you're not going to have enough time on tests and quizzes to figure out every time you need it, so you memorize it. In virtually the same method, we could also show that the derivative of cosecant x was negative cosecant x cotangent x. So, summarizing everything, and you have to memorize these. The derivative of sine x is cosine x. The derivative of cosine x is negative sine x. The derivative of tangent x is secant squared x. The derivative of cotangent x is negative cosecant squared x. The derivative of secant x is secant x tangent x. The derivative of cosecant x is negative cosecant x cotangent x. Notice the derivatives of all the co-functions are negative. So that'll help you remember where the negatives go. The derivatives of all the co-functions are negative. Now note, it will not be the case that the derivative of sine 3x is cosine 3x. That is not going to be the case. So far, you only know how to differentiate trig functions when the argument, the angle, what we mean by argument is whatever is following the trig function, when the argument or the angle is a simple plane variable, meaning x, p, q, t, theta, alpha, beta, just a plane variable. If it's 2x, you don't know how to do it yet. If it's x squared, you don't know how to do it yet. Once the angle changes to anything other than x, or whatever the variable happens to be, the derivative will be calculated by not only using the above facts, but also another rule called the chain rule. Right now, all you know about is when the angle, the argument, is a simple plane variable. Change it to something else, and it's going to be another rule. And that's where we will end this lecture. Or this video, not the lecture. We will go on for the whole section and many videos after this.